We're going to do a problem about kinematics. And this is going to be free fall. And free fall is in one dimension, 1D. And the acceleration is going to be g minus g equal to the acceleration. And it's going to be motion in one dimension. It's going to be motion with constant acceleration. And here we go. We have here, this is your floor, the surface of the earth. And you're going to launch a particle. You have a particle in your hand. And you're going to send it up with an initial velocity. Let's say you send it this way. This is the path it's going to follow. And then it's going to stop over here. And the initial velocity that you're going to give this particle is going to be VO in the Y direction. And it's going to be 25 meters per second. And then it's going to go straight up, and it's going to reach a point where he's going to stop. The particle is going to stop, and the final velocity there, the final velocity in the Y direction, let's put the final velocity, is going to be 0. And then it's going to come back down because it's going to go all the way to this point, and then it's going to stop because it's coming back down. So this would be your maximum height because it's not going to go further up. So it's going to be maximum height, and we're going to calculate that maximum height. And we can also calculate the time to reach the maximum height. We can calculate that, and we can calculate the maximum height. And we can use these equations. Delta Y is equal to VOT minus 1/2 of GT to the square. And the final velocity in the Y direction is going to be equal to the initial velocity in the Y direction minus GT. So we could use this equation because the final velocity is going to be 0 over here. So 0 is equal to 25 meters per second. We can say that G is 9.8, but we can approximate it to 10. Approximate it to 10, there you go. Minus 10 T. Let's put the units here. Let's not skip the units so we can see what's going on here. And this is going to be meters over second square multiplied by the time. So we can send this over here. So you got 10 meters over second square is equal to 25. This is the T right here, is equal to 25 meters over second. And then we can divide this by 10 meters over second square and divide this by 10 meters over second square. And we have 2.5, that's what we get. And then we get meters times seconds because we got a fraction here and a fraction here. So meters times seconds. And we got meters seconds to the square. So this one cancels with this one cancels with the square. And your time is going to be 2.5 seconds. So you got the time to reach the maximum height. That would be your first answer. This one right here. It's going to be 2.5 seconds. And to get the maximum height, we could use the second equation right here. We could use this equation. So the maximum height is going to be, we can do it right here. The maximum height is going to be delta Y, whatever we get from there. And that's going to be 25 meters per second. And we got the time now. The time is going to be 2.5 seconds minus, it's going to be 1/2 of G. So it's going to be G over 2. G over 2 is going to be 5. So it's going to be 5 meters over second square times 2.5 seconds, but elevated to the square. So delta Y, which is going to give us our maximum height, is going to be, if we do this, this is going to give us 62.5. second is going to cancel with the second. So you got meters right here. Minus, this is going to be 5 times that is going to be, this is going to be to the square. 2.5 seconds to the square times 5 is going to throw you 31.25 meters, because this is going to be second to the square over second to the square. Right here, this one is going to cancel with this one, and you got only meters left. So your answer is going to be 31.25 meters. And that's going to be your maximum height right there. And well, you can also calculate the time it takes to get to a point 5 meters above the ground. Let's say you have a point here. This is your height. And let's say it's 5 meters. And what's going to happen is that your particle is going to go up and it's going to go back down, and it's going to pass through this point right here. Through this point, it's going to pass twice. It's going to pass at a time t1 and a time t2, because it's going to go up and then it's going to come back down. And we can calculate those 2 times, which are the times in which the particle is going to pass through a point that is 5 meters above the ground. This is the ground right here. So let's do that. We can use this equation again. So it's going to be 5. It's going to be VO, which is 25. T minus 1/2 of G, T to the square. So this is going to be 5 equal to 25T, and G divided by 2 is going to be 5, T to the square. And we can divide by 5, divide by 5, and divide by 5. So we get 1 is equal to 5 here, T minus T to the square. And we can say that this is a quadratic. It's going to be T to the square minus 5T plus 1 is equal to 0. And remember that A is going to be equal to 1, B is going to be equal to minus 5, and C is going to be equal to 1. So our T is going to be minus B plus minus the square root of B to the square minus 4AC divided by 2A. So our T is going to be minus B, but who is B? B is minus 5 plus minus the square root of minus 5. Minus 5, there's your minus 5, elevate to the square, minus 4. A, which is 1, and C, which is 1. And this is divided by 2 times A. There you go. So you got your T1 and T2. So T1 is going to be, T1 could be, anyone could be 0.21 seconds if you solve this quadratic equation. And T2 is going to be 4.8 seconds. So these are the times it takes for the particle pass through a point. These are the times it takes to the particle to pass through a point that is 5 meters above the ground. This point right here. In its way up, it passes through the point 5 meters at the time 0.21 seconds, and then passes again when it comes back down at the time 4.8 seconds. And there you go. You got another problem here. Thank you. Bye.